All right, for the first part, what we're going to talk about on this section is going to be what a polynomial is, how do you evaluate one, and then end behavior of a graph. We are not going to graph today. Okay, all it's going to be is just whether or not it's a polynomial and evaluate them and then figure out what the end behavior is. So, first of all, a polynomial definition, just so that you guys know what I'm talking about, is either a monomial. Does anybody remember what monomial means from Algebra 1? One. Right. One term. Or a sum of monomials. What's a sum? Total of what operation? Adding. Okay. So we're going to, for a polynomial, basically what you're going to look at, you guys, is you're going to look at ones, we've already dealt with polynomials. Last chapter we had quadratics. That is actually a polynomial. You just weren't calling it that. Now I'm going to throw in there things like x cubed, x to the fourth, x to the fifth, all that kind of fun stuff. Okay? So that's what you're going to see when you see the ones for this chapter. It's not going to be squared all the time. Or it's not going to be 5x minus 3 or something like that. What a polynomial looks like is, it looks like something like this. 7x to the fourth minus 3x to the third plus 5x squared plus 2x minus 9 or something like that. That's an example of a polynomial. Now, what you're going to do on the first part of the section today is you're going to tell me, is this a polynomial, yes or no? Now, for this particular thing, this is a polynomial because I told you it was going to be one. One of the things that you can't have when you're dealing with polynomials, you cannot have fractional, or you cannot have x's or variables in the bottom of your fractions. Okay? Therefore, meaning you cannot have negative exponents. Okay, that's one thing that you'll see when you see that, is whether or not it has a positive or negative exponent. This one's okay because I told you it was going to be one. Now, there's a couple things that I'm going to explain as far as definitions go with this that you're going to hear me use throughout the chapter. First thing that I'm going to talk about is that exponent. That exponent is known as the degree. The degree is nothing more than the highest exponent. No matter where it's located at, okay, I can jumble everything around if I need be. The highest exponent is always the degree. That is something that's going to be important when we talk about end behavior in a few minutes, is what's the degree? Okay? All I'm asking when I say that is, what's the highest exponent? So are you okay with degree so far? Okay. The next term that you're going to hear me use is you're going to hear me use the word coefficient. Coefficient means number in front of letter. Okay? That's what coefficient is. So the 7's a coefficient, negative 3 is a coefficient, 5 is a coefficient, and 2 is a coefficient. Why isn't the negative 9 a coefficient? Doesn't have a variable. Right, doesn't have a letter. Exactly. The ones that don't have letters is known as a constant. Without letter. Okay? And then I have one more thing with it, just to add in a little bit more, is I also have what we call a lead coefficient, which happens to be the number 7. And a lead coefficient is the number in front of degree. Okay? These things can be jumbled around. So if I were to put x to the fourth somewhere in the middle, wherever the highest exponent is, the number in front of that is the lead coefficient, not necessarily the one in the front. I put it in order, or what they call standard form right now, And the reason why I did that, just to kind of give you an easy one to start with, is do you see how it goes? Exponents go 4, 3, 2, 1, none. Okay? That's what they refer to standard form. So if you see ones that go 5, 4, 3, 2, 1, that is in standard form. If it's all messed around, it's not in standard form. So they're going to ask you to put it in standard form. And you're going to have to do that throughout the first part of the chapter. You might have to switch some things around. Okay? Is it adding or subtracting to one or the other side? No. All it is moving it into different locations. Like if I said, Abby, why don't you go move to that back group? I didn't switch the problem or didn't switch the class. I just switched where she was at. Okay? So, on this particular thing, here's what they're going to ask you to do. If I give you something like this, where it says g of x, negative 0.8x cubed, plus the square root of 2x to the fourth, minus 12. The directions are going to say, decide whether the function is a polynomial. If so, write it in standard form, state its degree, the type, and leading coefficient. So first and foremost, looking at the exponents, are any of them negative? Exponents. Are any of the exponents negative? No, they're not. The first exponent's a 3, the second exponent's a 4. So am I good? Yeah. Okay, so if it is a polynomial, if we figure that part out, is it in standard form? Is the highest exponent listed first? No. So I need you to rewrite it. What would come first? Then what? Then? Minus 12. I put it in order. Awesome. Now, the next thing that I wanted you to do was to state the degree. What is the degree of this polynomial? Huh? 4. Why was it 4? Because that's the highest exponent. Okay? So it's a degree of 4. The next thing that they're going to have you do is it says to tell me the type. Now, here's what they mean by type. So far, we've dealt with quadratics. What did quadratic, that word, mean to you as far as exponents go? Squared. Right. So when I said the word linear, do you guys remember me hearing the word linear? What was the highest exponent then? On a line. 1. Okay. On this particular thing, what's the highest exponent? 4. So that is known as a quartic. Okay. Highest exponent was 4, so it was known as a quartic in this particular part. Okay. If it has highest exponent of 3, it's known as a cubic. Now, just so that you guys know where I'm getting that, there's a chart on the middle of page 158. It gives them to you. If there is no letter, it's known as a constant, just like we had for the negative 9 in that first one. If it has x and then whatever, like just x to the first is the highest exponent, that's a linear. If x squared, that's a quadratic. X to the third, that's cubic. X to the fourth, that's quartic. X to the fifth is called quintic, which is not on there, but it does, not that you're going to see one. And then anything higher than that, they start giving you just degree of 6 or whatever like that. Okay? So just so that you are aware of it. Then the other thing that they want you to tell me is what is the lead coefficient. I abbreviate lead coefficient as LC. Square root of 2. How are you guys okay with that? Can you guys handle problems like that? What if it wasn't a polynomial to begin with? Would you have to do anything with the degree or with any of that stuff? No, you wouldn't. So if you determine it's not a polynomial, you just say it's not one and then you move on. Are you guys okay with that?
Yep.
Okay. The second thing that you're going to be asked to do is you're going to be asked to evaluate it, which means something like this. If it says f of x equals 2x to the fourth minus 8x squared plus 5x minus 7 when x equals 3. What are they asking you to do?
Plug in 3 for x.
Abby says plug in 3 for x. Does anybody else agree with her? Some of you are shaking your head yes. That's a good thing to do. Agree with Abby. Abby's right this time. Okay? So on this particular thing, what they're going to ask you to do to evaluate, plug in the number 3 and let's see what we get. Be very careful when you plug it in. Plug it in. Okay? Because some of you will still mess it up. Whenever you insert a number for a letter like that, always, always, always put it in parentheses. Why do I put numbers in parentheses when I insert it? It's all because of the sign. So, the nice thing about your calculators is your calculators can handle the whole thing because it does understand the order of operations. You could type in this exactly like it is and you will get the answer. I don't have a calculator, so I'm going to do this old school way, and that is using the order of operations. First thing that should come is 3 to the 4th, which is 81. 81 times 2 is 162. 3 squared is 9. 9 times negative 8 is negative 72. 5 times 3 is 15. Minus 7. 162 minus 72 is 90. 90 plus 15 is 105. 105 minus 7 is 98. That's what I got. Is that what you guys got? Pretty good. Okay. Are you guys okay and comfortable with evaluating? When it says evaluate, all you need to do is plug the number in for the letter and let's see what we get. Be very careful when they put negatives in there. Because if you don't put it in parentheses, guess what's going to happen? It's not going to come out right. So be very, very careful. Are you guys comfortable with evaluating? Good. Now, the last thing that we're going to talk about is what they call end behavior. Okay? What end behavior is this. What's happening on the ends of the graph? Okay, and we're going to set you up because on Monday we're going to talk about how to graph these. Okay? But we're going to talk about end behavior as far as what happens on the ends. Because here's what happens a lot of times with you guys, especially the first time you do it. If that's your viewing rectangle, like this, and you see this thing that comes in here and you go, oh wow, I've got a great window, that's awesome. But realistically, what should have happened was this. Is that window any good? No, it's not. So end behavior is a way to help you determine if your window is good or not. Okay? And all I'm referring to with end behavior is what's happening on the ends. You have 4 options. Option 1, hopefully we see a lot of this tonight, would be that they both go up. Right, Amar?
Yep,
Hopefully. Option 2 would be that they both go down. Another option 3 would be that one goes up, one goes down. And then option 4 is the other way. Okay? Just like I'm dancing. So, here's the different options. I'm going to put it in terms mathematically, and then right underneath that I'm going to put it in easier terms to kind of understand also. Okay? So the first thing says this. As x, hold on, don't write that yet. When you find or look at end behavior, there's 2 things that you need to identify in your polynomial. The first thing that you need to figure out is the degree. And the second thing that you need to figure out is the lead coefficient. I abbreviate lead coefficient as LC. Okay, so when you see LC, you're going to assume or know that I'm dealing with lead coefficient. Okay? So, if the degree is an even number, versus an odd number. Do you guys know what I mean by evens and odds?
Yes.
What are even numbers? 2, 4, 6, 8, blah, blah, blah. What are odds? 1, 3, 5, 7, blah, blah, blah. Okay? So when we're dealing with even versus odd, that's what we're going to have. The other thing there, the next thing that we're going to do, and that's for the degree side of it, is the lead coefficient is either going to be positive or negative. I'm just going to move my even over here a little bit. Okay? If the degree is even and the lead coefficient is positive, here's what happens. As x approaches negative infinity, the function approaches positive infinity. Again, I'm going to give them to you in mathematical terms first, and then right underneath it in a different color, I'll tell you what it means. So leave some space so that way you can actually figure out what x approaches negative infinity means. And the other side too. And as x approaches positive infinity, the function also approaches positive infinity. Now, let's see if you guys can figure this out. When I say x is approaching negative infinity, which way is x? Left and right, right? Okay. Which way would the negatives go? To the left. So guess what x approaches negative infinity means? Left. What do you think x approaches positive infinity is?
Right.
Good. Okay, it's left and right. So that really means as I go left and as I go to the right. That's what those refer to. What do you think f of x approaches positive infinity means? What is f of x the same as? Do you guys remember? We've talked about it before. Y. So which way is positive infinity on the y-axis? Up. Good. So this is what it really means in layman's terms. When you go left, it goes up, and when you go to the right, it goes up. That's what that means.
Is it never going to go down?
That's only the first scenario.
Oh.
So on this part, again, when the degree is even and the lead coefficient is positive. That's how it works with this chart. When the degree is even and the lead coefficient is positive, that's what's going to happen. If the degree is even and the lead coefficient is negative, as x approaches negative infinity, f of x will approach negative infinity. And as x approaches positive infinity, f of x approaches negative infinity. So what did x approaches negative infinity refer to again? As I go left, what do you think negative infinity on the f of x is going to be? Down. Good. What's x approaches positive infinity? Which that goes to the right. What's f of x approaches negative infinity going to be? Down. So, here's what we had so far. The first one said, as I go left, it goes up, and as I go right, it goes up. That's even and positive. If it's even and negative, as I go left, it goes down. As I go to the right, it goes down. Have you had parabolas that open like this before? Parabola is a polynomial, and you've had ones that go down. Think about what happened to make it go down. It had a negative in the front. That was a reflection over the x-axis. Remember when we did that? and it went down, that was because it was negative. Same thing here. It's not any different. That's both up or both down. Okay? Now the next one. If it's odd and positive, as x approaches negative infinity, f of x approaches negative infinity. And as x approaches positive infinity, f of x approaches positive infinity. What does x approach negative infinity mean again? On the left side, where is it going to go? Down. And what's x approaches positive infinity again? The right side, what's it going to do? Go up. So like this, if my odd positive, so on the left side it goes down, and on the right side it goes up. Think of a line. Think of slope. When you were a positive slope, which way did it go? This way, right? Uphill. So, without me writing the next one, what do you guys think it's going to be? What do you guys think the last block should be? As x goes to negative infinity, f of x is going to go to positive infinity. I listened to Abby. She said up first, then down. As x approaches positive infinity, so left, right, up, down. What it's going to ask you to do on the problem is, it's going to give you a polynomial and it's going to say, describe or determine the end behavior. This is the answers. It's one of these four scenarios. That's the answers. You just have to determine what it is, or which one. Are we good? Okay, so here's what it's going to say. It's going to give you a problem and it's going to say f of x equals negative x to the third plus x squared minus 7x to the fourth, and I want you to describe the end behavior. So what I need you to do is identify what's the degree. 4. I put it in a different order. 4 is the degree. Does everybody see where it's 4? Okay. Is 4 an even number or an odd number?
Even.
Even. So we're going to be in the even column. Is the lead coefficient then positive or negative?
Negative.
What is the lead coefficient, by the way, then?
-7.
Good. Not -1. So -7 is it. So we're looking for negative and even. So what's my answer? I'll give you a hint. X approaches negative infinity. X approaches positive infinity. It's always going to be those. But then what's the back end of it? Negative infinity. And then what about the next one? It approaches negative infinity. It's an even. So I go to even. And it was negative, so I go to that one. And it looks like they both go down. This is the left side, this is the right side. This is the answer, right here. Yes. Yeah. Well, yeah, because you don't just do the left side of it. You don't get ready on just the left side of your body, do you? No. Okay. So when it says describe the end behavior, that's what your answer is going to look like. All you have to do is figure out where does it fall in the chart, and then whatever that is, that's the block that you write. What do you guys think? So the first one's going to ask you to identify if it's a polynomial or not, then write all those different pieces. Second part is going to say evaluate them. Third part is going to say determine or describe the end behavior. So it starts on page 162. 3 to 19 odds.